All right, so in this one, last time, it was on Friday, Skeptic mentioned that I should have an RC circuit at the reset. So I want to investigate what that is. I don't know, I have no idea, zero clue on what a RC reset circuit is. And I thought, why not do it while I'm live streaming, you know? It would be better for everybody, I think, to learn with me, unless you guys already know about it and you can give me some information. Yeah, Sledge-O-Matic. Okay, it's for, well, the RC circuit for a button would be for debouncing, but for the reset, is that the same thing? Is it for, because what I was thinking is for the reset condition, for the microcontroller, it would be, it would put it into a reset state for a certain amount of time. But I have no idea what it's about, so that's just a guess. So I'm gonna, there's, like I was saying in the previous stream today, the one that I had to cut off unfortunately, was I have three resources. I have Google, I have ChatGPT, and I have Claude, and I can ask them and see what they say about it. I was gonna try ChatGPT first, and then that's when my keyboard decided to fail on me. By the way, do you recognize these things? What these things are? I'll give you a closer view. Okay, yeah. So since you cannot debounce it in software, you have to debounce it in hardware. Yes. Okay. We'll see what that means. So what do you think this is? Bob, I don't think you were here yesterday. I did a stream yesterday and we did some stuff. And I think it was you that suggested that I do the lasing rather than the cutting with the box cutter. Was it you? Hey Jabathia, thank you for coming back. Add 100 nanofarad caps to debounce. Oh yeah, we're not doing button debouncing, we're doing reset. I was here for a little bit yesterday. Yeah, okay, cool. Oh, you suggested no laser. Okay, who was the one that suggested the laser? I can't remember. All right, so let me go to ChatGPT. Okay, the reset button. Well, there's no reset button here. It's just a reset condition. So I don't have a reset button. So was Skeptic talking about a reset button? That's where I'm confused, I think. Because if we're gonna investigate the RC, I don't think I really need to investigate the RC circuit for the reset then. Because I don't have a button. I'm not gonna put a button on the reset because I don't really need to, unless I need to add a reset just to reset the microcontroller and make it so that part works right. But what am I trying to think? The act of, I guess, or the process of flashing the microcontroller, I'm thinking does some kind of reset to the microcontroller right before it does the flash. So that's where I'm thinking what he was talking about. Okay, yeah, probably Skeptic. I don't think CNC did it. He came in late. But yeah, I did this. And also I did the final lasing on the very top of the 3D printer cover. I did the top with the laser. So I cut it with the laser. It was a super beautiful cut. And then I started cutting holes in it for the hinge that was on the top. And I also installed the hinge yesterday. If you are driving the reset pin from the programmer, you don't need an RC circuit, or at least you shouldn't. Yeah, so maybe I'll just skip that. Maybe I'll skip that for today, and I'll get into another thing. And Skeptic isn't here. He can give us more information when he comes in, if he does come in. He or she. I don't know if it's a she or he. So, Skeptic, I'm assuming. North Korean TV, nice. See, watching their propaganda. Okay, so yeah, these are the holes that were lased for the. Whenever I try to think of that word, I can't think of it. Hinge. Get it in my brain. All right, so I'm going to plug this sucker in to power it up so we can see something happen. What should we put on the screen today? Oh, and by the way, I got something new. It's another screen. So I'm going to be putting these screens in I think the intermediate kit and the advanced kit. I'm going to turn off my notifications on my phone so that doesn't bother me. And this one has a different color, I think. I think it may be all blue or all white. I'm not really sure. So I wonder if this is going to work just the same. Let me turn up the ISO a little bit. So I'm curious if this is going to be like a sort of a plug and play. I gotta see if it's the same pin designations. You got ground, VCC. Yes, classic AliExpress packaging. And thank you for coming in, Rick. How are you doing? SCL and SDA. So ground, VCC, SCL, and SDA. So is this the same? Ground, VDD. Oh, well, it's the same thing, VCC, VDD. Oh shit. No, they're the same. Okay. I thought the SDA and SCK were, I apologize for my French, are switched. I don't usually cuss. So I'm going to unplug this one and plug this one in and see if we get the same thing. And then you guys can tell me what you want on the screen, and I'll change it. All right. Hopefully it has all the right timings and it should be all the same. And if it's even good, I mean, maybe this is a dud. You never know. So I will remove this one. I'm going to put the camera really close to it so I can see what's going on too. Because my eyes aren't that good, and the camera serves as a really good magnifying glass for me. I'm 56 years old. I'm getting up there. I'm starting, but I don't feel it yet. All right, that's out. This is delicate, a delicate operation. So it's these two right here. I think it's these two, right? Yeah. All right, so we've got ground. We got ground and VCC, and we can see where those caps are. We got the SCL and the SDA with those two lines. Yeah. Okay, that looks good. All right, so since it's I squared C and the data is serial, it should work. Yeah, it should work. My biggest fear would be it not working because of some issue with the screen itself, or if it even has a different driver, but I don't think it would be. Let me see if let's actually look at that. We can look at the number maybe right on the, that's not it. Wait, I think it's too close. No, there's no number there. Usually there's a number on it, but okay. We'll try it. Let's plug her in. Who thinks it's going to work right off the bat? Put a 1 in the chat if you think it's going to work. I'm going to plug it in 3 seconds. 2, 1, 0. Let me manually reset it. Okay, it worked. This is the white one. Yes. Hey, Jabathia, thank you for coming back. Grateful, thank you. Should I take off this part right here? Do I dare? I will do it. Here we go. Nice. All right, so what should I put on the, yes, the keyboard epic fail is over. It's done. When I started, I had the stream back up in like a matter of seconds actually, and the keyboard was working fine. But then this camera decided to not work. So I had to reset my computer like twice. I had to figure out why it wasn't working. I disconnected the USB cable. I changed settings in my camera. I did everything I could think of. And then it just worked after trying a bunch of things that I can't remember what I did to make it work. So that's the unfortunate thing. All right, so we got this new one to work. So let's see. What shall we put on the screen? Yeah, we don't have, I don't know how many people we have in Twitch, but I'm still not holding my breath. I got one viewer. Hey, viewer in Twitch, thank you for coming in, whoever you are. Okay, so, and participate if you feel the urge, the gumption, the desire, the will, the courage. I know not everybody is outgoing. I'm not either. I'm pretty shy myself. I have spastic bowel, unfortunately. So every time this Twitch starts, I have to use the bathroom. Not Twitch, I mean the live stream. All right, let's see. Don't be shy. Let's see, protective plastic, yes. Most of them use the same driver chip, and if not, it's usually a header file difference, yeah. And you know, I'm not using any libraries. I'm doing my own stuff here. Let me show you. I'll scroll slowly. All of this is Scratch programming by the famous Claude. No libraries whatsoever except for I'm using these standard libraries and main.h, which is really, I'm just including this stuff right here, which is just the chips, macros and stuff. By the way, am I clipping with the mic, or is it, because maybe when I started this whole live stream thing, I wasn't really speaking loud enough. Maybe I'm speaking too loud now. Yes, the infamous Claude. Well, we'll see how infamous it is in the future. All right, so I guess that's good. Infamous Claude provided this. Not sure if Wonderful is gonna fit. And this is barely viewable. This stuff right here is barely viewable by the naked eye, at least my naked eye. So I'm gonna go ahead and play it, flash the microcontroller, and see if it changes the screen. You can see what it looks like in the output. Looks like it worked. All right, nice. So now I don't have to worry about that yellow on the top. That was kind of bugging me. Was it bugging you guys? All right, cool. And also, you guys can see more of what this looks like from my perspective, because it actually kind of looks bluish in real life. It has like sort of a bluish tinge, just like a lot of whites do. All right. Okay, so what do we do next? I guess we continue with, we've already looked over all of the OLED commands. And we've looked at the horizontal scrolling. There's a couple things that I want to do. One of them is obviously go over the remaining code, which is like setting the cursor, clearing the screen. We can also play with maybe some different characters, maybe some alien characters, and also drawing a pixel, drawing a line, and drawing a rectangle, and drawing a circle. And these don't work very well, by the way. So we can also investigate that. What do you guys want to do? I can, and also the ADC, I want to start putting the ADC data here and putting in the ADC code in this code, so we can take a look at some of the code here. So whatever is more fun for you guys, do that. Sometimes they create white with via blue with a yellow filter. Yeah, the one that I had before was the two first lines was yellow because of it's kind of a status area, I think. Okay, let's do the ADC. I like that too. So I'm going to go back to my ADC, and I'm going to steal some of the code there because I've already explained all of that code. We did that from scratch. So I'm going to have both of them open as tabs here. So we already know what all this stuff is. Unless I could do a quick review if you want. But it's pretty easy and quick. I mean, it's just we don't really need to initiate the HAL stuff, but we do anyway. We have the system clock config, which we're not going to be doing in this one. This is probably 8 megahertz, and we are running 48 megahertz in this one. So that's going to be an interesting difference when we see what happens with the clock. But the ADC is using its own clock, so it may not be running at the same speed as it is here because it's using that other clock. That would be interesting to make an oscilloscope out of it. I was thinking about that with the horizontal scrolling, and we could do that with the ADC, but let's start simple, and maybe we will ramp up to that over in the future. So that would be a good idea. If I can actually figure out how to get, like with the horizontal scrolling, I would have to update just this line here, the 128th line, as it scrolls to the left. So I could do that manually, and it would be a lot slower that way, but using the horizontal scroll, I could do that sort of like the scroll happens like one step every 5 frames, which I don't know if that's going to be, or every 2 frames, I think. And then I update the rightmost line here. So I have to figure out how to do that. It shouldn't be too hard. Okay, so the next thing is it's just the initialization for the ADC, and I can put all of this inside of an init function. So let's do that. I'm going to copy that, and I'll create an init. I'll do a prototype first. I could just put it inside the main, but why do that when we could do this? I don't think I'm going to be putting any parameters inside of there. Let's see, could I? Not really. I could do the parameters of number of channels. So I could do that, but let's not do that yet. I am using the STM32 F030 R8T6. It's a 64-pin package. It is one of the lower. It's an F0, so it's like I think it's an equivalent to an M0 for ARM, but it is it's a relatively simple chip. It has a lot of features, but I will also be upgrading to another chip for future projects as well, and I'll also get into ESP32 since that has been requested. So it's just bare chip. We're not doing anything fancy. Bare chip on a breakout board with nothing on it except for pins going into white breadboard, and then on the breadboard is where the circuit lies. We have 0.1 UF filter capacitors on all the main power lines. So this is a development environment or platform that I've set up over many years, just for people to learn the bottom-up approach and learning from the programming from the ground, like register level, all the way to making your own circuits. So in my opinion, it is the best way to get started with microcontrollers, because starting with Arduino, you're doing the top-down approach, where you have to essentially reverse engineer if you ever got a job as an engineer, if you ever wanted to go to that route. Oh, all right, so after that, let's see. I'm using an Adafruit ESP32 feather for a camera slider rotator. That's pretty cool. That's generally a one-off project, obviously. So you're doing that for yourself. That's really cool. Hey, Skeptic, how's it going, man? I had a question in the beginning of this live stream, if anybody knew what this is from. Do you have a guess? Hey, Rick, if you want to shout out your YouTube channel, go right ahead. What does this look like? To me, it kind of looks like a ruby, actually. All right, what's your guess, Skeptic? The color should give it away. Is it too dark to see? All right, you probably need a scale to determine like what size it is. So this is my hand. Nope, it's not a plug. It's not a copper coil. This is red. This is like almost ruby looking. I'll give another clue. It's probably acrylic. I'll keep it in the shot for you guys to ponder. I think I gave it away already in the last stream, or today's failed stream. Okay, I'll go ahead and tell you guys what it is. It is part of the 3D printer cover. This is a hole that was lased out of it using the laser. And I can't remember if it was Skeptic or somebody else that suggested that I laze the cut rather than using a box cutter to cut the... No, it is actually a real cut for one of the screw holes for the hinge on the top of the 3D printer cover. It was Bob. Bob said he didn't do it. He said it wasn't him. I thought it was Bob too. I was like hitting myself in the head, like, why didn't I think of that? Not I, Bob says. All right, so now we have the mystery of who asked. I have that in the live stream. So, but I did do the lasing of the last cut yesterday, and I had that on live stream, and it was super fun to do. It was a little scary because I hadn't used my laser in such a long time, but it was and it was very fumey in the garage as well. I guess that leaves CNC. Don't know what that means, but yeah, I could have used the CNC machine to do it, but that would have made a huge kerf. I don't want to do that, but you may have meant something different from that. Okay, so let me go back to this, the ADC init. Let's put the ADC init in here. I'll put it right at the top. I love when it doesn't tab correctly. That looks right? So now we can go ahead and initialize it in the main area. You know, I really want to use a different accelerometer for this, because the other accelerometer is a 2000G accelerometer, and it's hard to get anything responsive from that. I'm going to do it anyway. It's going to be the simpler way because I already have that going for me. Although I could, let me get another one just to see how hard it would be. Oh, CNC lathe. No, it wasn't him. I don't think it was him. I think it was somebody else. Barometer that I could also do. And that's going to be a lot easier because all I have to do is tilt to get that one to show any response. But I'm going to have to solder and stuff. By the way, tomorrow in the CNC live stream, I'm going to be putting a spindle together with a VFD. I'm going to be connecting those two together and going through the parameters and stuff. Maybe if I get the components in time. So you might want to come around if you're interested in that. So this is a, let's see what the headers say. Okay, so we have ground, VCC, CS. Oh no, this is a, yeah, no, this is I2C. This is not ADC. So I mean, I could do this too. I could do this as well, and this would be an interesting circuit to put aside another I2C circuit, because they would have to work on the same line. Or I could use the I2C2 if I have the I2C2, so I could use that as well. So that's something we can do later on. So I'm going to use the same 2000G accelerometer for this one. All right, so let's continue on. Oh, by the way, I do have this one. I have all of the code tutorial and everything that I did a while back, like 6 years ago, for this I2C and making this thing work. It's on my Vimeo channel though, so I'm gonna probably put that on my main channel soon, and I'll probably do it again because I was using Kucox Co-IDE to do this one. The code is the same, so it would be interesting to do this again with the STM32 IDE. Rick, I am working on a CNC plasma table. It's a winter project. Last winter, I got all the power supplies, steppers, and controllers wired up working. Awesome. Yeah, you should definitely come and watch my CNC stuff, or come here during the Tuesdays and Thursdays at 1 o'clock. I talk everything CNC. I do CNC experiments. And, the theme has been shielding for the last week, last couple weeks actually. But we also were looking at phenomenon on how a motor it does a thump during a stop through an increase in acceleration. So that's some of the things we're working on, but I have no problem doing all kinds of other experiments as well. Okay, so Rick, you work during those times, but today I'm off. I'm subscribed to the channel so I don't miss much. Yeah, you can always watch the live streams, but I only keep the last week, and the older ones go straight to the membership area. So be sure to catch it before it goes bye-bye. All right, so we have here, I would say I'm going to do the ADC before the I2C init, but after the system clock config. If you want, yeah, definitely become a member. It's I put a lot of stuff in there. And I also put the supercuts of these live. It takes about an hour out of the entire video. So what I do is I remove all the silent portions of these videos. I put it straight into the membership area, and I call it livestream supercut. So if you want to save some, I equate memberships these days of memberships with YouTube channels and stuff is like being subscribed to magazines in the old days. Okay, so the ADC init, and I hope I am putting enough information or stuff to bed daily, or at least during the weekday. Okay, so the ADC is in there. I want to try to go ahead and play it. I want to see if I have any errors first. So I'm going to play, and I'm going to put this in MC2 or the other scene. I'm pressing play now. Okay, I don't have any, there are no errors, so that's good. Webmaster saying, where did I see you at WA, Washington? Unusual cooling for a water spindle. WA, I don't know what WA means, but yeah, I use a CPU type cooling for the spindle. Generally for like Chinese spindles, they use the bucket and pump method. So they just fill a big bucket with water, and they put the pump, submersible pump inside of that bucket, and they feed that to the spindle. But what I do is I use a water reservoir, pump, heat exchanger, and I put all of that on the z-axis right next to the spindle. It's very, very compact. All right, so the ADC init is there, and now I want to start the ADC and grab the data. Let's see, we're starting the ADC. We're checking for end of conversion for the ADC first channel and then the second channel, and I'm getting the maximum values of these so we don't miss anything. So this should be good. So let's put that in the other program. I'll put it after this because I'm still going to be, well, I'll put it before it because I'm going to want to put the value on the display immediately. Hey, Tigger. My cat has entered the room. All right. So let's put this on line number 4. So let's put the actual number. Oh, I need to convert. I'm going to need to convert the number to. So what was that again? All right. So I'm going to have to create a buffer. So we used about. Oh, let's go ahead and use 10 again. We could use just the whole line's worth. All right. So let's see. Here we go with the sprint fiasco again. Sprintf. Who remembers? I may have to look this one up again. Oh gosh. Was it? Let's see. Cat. Can you stop writing on the keyboard? Cat. Oh my God. The cat is moving the camera. Ugh. All right. So the cat has entered the room. You can't see the cat. Oh well. Sorry. I was going to show the cat off. But he was on the top of the table, and you could. He was like moving this camera around. Yes, the cat is interested in when I'm ignoring him. Only when I'm ignoring him, he's like, okay, you need to pay attention to me, not anything else. All right, so we sprint F. Give me a sprint F, people. Hey, there's somebody in the chat of Twitch. Yodathan1. Welcome. You're the first person in a long time in the Twitch side. So thank you for coming in. This is not Arduino. This is bare chip microcontroller stuff. So we are working very low level here. And it's easy stuff though. So don't, if you're used to Arduino and you're timid of getting into this kind of stuff, I do it I try to show it in a very simple and easy way. It's the way I think everybody should start, but that's my opinion. All right, so sprint F. I'm gonna go online. You know what? I'm gonna ask ChatGPT, my buddy, my friend, ChatGPT, or Claude. Claude is probably better. And see what is the way to convert a integer to a string. I said C, not C++, so let's see what it says. Okay, it uses sprintf. All right, so it's using 12, the array of 12. It doesn't have an address, so that's interesting. So let's go ahead and do that. And then the %d, I guess, is decimal, but it wouldn't be decimal. That would be, because I specify integer. So what is the d? What is the %d? Let me ask it, actually. Assigned integer. Okay, good. Thank you. Thank you, Bob. All right, now we got it. All right, so let's go ahead and put that in. All right, so the string is going to be buffer, and then the value, I'm going to use the ADC max. So that should work. Let's see if we get a value on the little display here. At least a value. We should get some value, even if we're not even using it, because we have nothing connected, because they're connected to these 3 positions here. So we're going to get just a tri-state value, which is just an interference value, which is probably going to be close to 0, probably. All right, so let's try it out and see what happens. What do you think is going to show up, actually? What number do you think is going to show up? Because we have 4096, and the vref is default. So that means that we're using 0 to 3.3 volts. What do you think is going to show up on line 15, 16, line 15 and 16, well, line 15 in this case? Do you think it's going to be close to 0 with just nothing there? Let's find out. I'm going to try it. I'm pressing the play button. We got fatal errors, so let's see what happened here. Okay, we didn't declare. Okay, we have to do that first. Duh. Let's get our variables. We'll put it at the very top. All right, let's try it again. I like to be in the main. So we should get a. I'm going to go ahead and press play, and you should see what's going on in the. Okay, we still have problems here. So the count is undeclared. So I must have that somewhere else too. Oh yeah, here we go. Count. I don't think I need an antenna. We have a whole bunch of tie strips in here, but I can put just a wire coming out of 15. I can also put in, oh, you know, I could do that too. I could put in a potentiometer to change the value. So we can try that as well, but let's go ahead and try this first. Just so you see, I'm putting in the count. So I have these values in there, and I have the count in there, so we shouldn't get those errors. So anybody have a guess of what number is gonna come out? I'm gonna press play. Still have issues here. Let's see. No, I do not want to proceed with launch. Let's see. This one Oh, yeah, we have to have a number in there. So let's put in buffer. Okay, let's do it again. Press play. There we go. That's better. We got 0. Okay. All right, let's put a wire in there. We could wire it up to 2+ volts to the power rail and see what number we get. I would want to do that with a resistor though. Let me get a resistor somewhere. I don't like to pull pins high completely, like just with a straight wire, only because I don't know what would happen and I don't like to short anything. All right, so I'm going to put a resistor while it's on, so I should get a higher value. I'm going to use a 330 ohm resistor. Let's see, am I putting it in the right spot? This is just a resistor I had on hand. Should be fine. Is that 15? That looks like 15 to me. All right, I'm going to show the well, I'll do this. See if I can still see the number. Oh, look at that. Check that out. It changed to 2000. I'm removing it. I wonder why it changed to 2000. Let me rerun this. It's 0 right now. Did it change to 2000 right when I put it in? I'm about to put it in right now just to see what happens. That's an odd phenomenon right there. Still 0. I didn't put it into a positive at all. I think it's in 15. Yeah, all right. Oh, it went to 2000. That's very strange. So when I put it to positive, it should change, right? All right, it's in the positive rail right now. So nothing. I'm gonna go ahead and run it again. Oh, wait, it's because of this. It's because of this. This 2000 right here. It's because we were, yeah, I need to change this to 0. Because before we were hovering around 2000 with that 2000 G accelerometer, which was around the half of the 3.3 volt range. And that seemed to be very slow too, didn't it? Yeah, it's not working. So let's go ahead and hook up the actual, what do you call it? Accelerometer. So I'm going to bring these back to 2000 and I'm going to find that accelerometer with the hammer. So what happened was the count got to 40,000 and then it automatically turned to 2000. That's why. All right, so where is that hammer? Okay, so here's the hammer. It has the 2000 G accelerometer on the very top of the hammer. If you didn't watch those live streams, or those videos actually, I don't know, was it a live stream we did this? I think it was live stream. So we put the accelerometer here. We did the testing with the ADC in STM32 and we got good values out of it. But we were only able to get the two channels to work, not 3 channels, the X, Y, and Z. And we decided to go to the OLED to take a break from that. So I'm going to plug this in. I think I remember the green being the X. So let me get really close here, and it's going to be in 15, 16, and 17. So X, Y, and Z. Let me see if I can get a better view of this without my fingers in the way. All right, that should be 15, 16, and 17. And then we have the power pins. And plus is near me and minus is far from me. So that should be right. So we got the red, this one on the red, and that's plus and minus. So that should be correct. I'm going to turn this back around and we should get some numbers. I don't even have to use if it's working right, I shouldn't have to use the hammer just to get some numbers out of this. I should actually just put the raw value there. Let me put the raw value instead. So the raw value would be like the X. Oh, this is a Y and Z. That's why we weren't getting any information, because it was the Y. I was wanting the X, not the Y. So this is the reason. So I'm going to take this out, and I don't want to get the Z. And it should be, let's go back up to the ADC. I think maybe I have the channels. Yeah, channel 2 and channel 3. That's why I wasn't getting any values. Okay, with the resistor. Okay, so I'm going to go back to channel 1 and channel 2. Channel 1 is pin 15. Channel 2 is pin 16. Yeah, the count got to 40,001. Yep. Do you want to make a non-contact end cap for CNC? Could you explain a little bit more about that? End cap? What does end cap mean? Is it like an end switch? All right, so let's go ahead and see what happens. I'm going to turn it on. And yeah, let me put the actual value instead of, because I want to see this thing change, the value change. And I lost my USB cable. Where is that? Okay. Okay, so we have the 0 there. Now if I run it, we should get some value hovering around 2000. Yeah, there we go. That makes a lot of sense. Okay, so that's the X value. And that is including a bunch of noise because this is a circuit on a breadboard. But that's actually pretty good. Okay, yeah, the axis limit switch. Yeah. I have a bunch of videos already for the proximity switches. So I do have videos out there, but I have no problem doing experiments on live stream with the proximity switches. And also I would like to get into magnetic Hall effect sensors to see how that works as well. And just put together a circuit and see if I could maybe we can test repeatability on a Hall effect sensor with a magnet. Okay, so we have 2000, around 2000. If I do I'll want to put the max value here, but I think I want to lower this value from 40,000 to something much smaller, maybe 1,000 or 10,000, because that was a long time, wasn't it? So it's going to, with this if statement, it should capture the highest value. But you know what I should do? I don't know if I want to print anything here because this is going to slow down the processor quite a bit. So I may only want to change to show this if this value changes. Who's with me? Like if something happens here, it will. I could give it a Boolean, which doesn't exist actually. I can give it another value to say print or something like that. I don't think I'm going to find. I'm not going to get any values here because this is going to be so fast. So I'm going to bring this up a little bit and see if I can get the. Actually, maybe I can do that on the other camera. Let me put the other camera on as well. So first, I want to change this. Let's see. Let's go ahead and just try it with the max first, and let's see what happens. So I'm going to turn on my other camera, and I wonder. Let's see. I'm going to move this stuff around a little bit. I'm going to try to get a wider angle on the other camera. Okay, that goes into the other region there. All right, so I'm going to point this other camera down. All right, let's see. Now you can see me hammering at the same time. So you should be able to see what's going on the screen and me hammering. What am I going to hammer on? That's the question. I'm going to try to get something tall. Is this too tall? No, it looks pretty good. I'm going to hammer on this edge here so it doesn't actually touch the table and cause all kinds of havoc. And I don't want to take these. Oh gosh, one's already been. Oh my God, look at this. I need to turn this off quick. The temperature sensor is touching one of the pins. So I'm going to put the temperature sensor in just a bare tie strip, an unused tie strip. There we go. Nothing is in that tie strip, so that was, holy crap. Turn this back on. I can't believe nothing actually happened. All right, this is how I reset. I remove this, put it back in. Sometimes it doesn't work, like right now. And why isn't it working? Did I blow something up? Okay, it's working. All right, for a magnetic sensor, I think you need a generator with an exciting coil and sensor on one side and a magnet on the other. If we use a Hall effect sensor, we shouldn't have to do that. A Hall effect sensor is just like it looks like a little transistor. But we can try something else too. That coil method could introduce some of its own EMI actually. All right, I'm going to bring this closer, move this so I'm not stressing the cable too much. And I see these want to move. Let's see if, I'm going to hit this other camera. I already hit the other camera. Let me get it back. All right, let's see if we can see oh wait, did we run the new one for the ADC Max? I don't think so. I'm going to run it again because we shouldn't be seeing that number. Well, we could actually. Yeah, you see how it's not changing very much? That's what we want. So it's only getting the maximum value. So let's see what happens. Nothing. 2016. See, this is a 2000G accelerometer, so it's going to take a lot. 2022. Let's go back to 2000. Okay, 2017, 2018. Oh, that was 2023, the last hit, I think. All right, let's see. Let's try it again. Didn't get hard enough. I'm going to let it go back down to 0. 2022. I'm going to let it go back down to 0. Man, it's hard to get any values out of this accelerometer. Wow. I'm gonna lower the number. Oh, this sensor is 2000 Gs. Tapping on it is not going to do anything. I'm going to lower, let me go back to here. I'm going to lower this value down to 2000. I think I also still want to, yeah, you know what? It may not be getting a lot of the values because of this. So I do think I want to put it in here. Only when that happens, it will print it out. Let me do that. Yeah, I think that's going to be better. Convert the ADC number to actual G. Yeah, I'm going to do that later on. Once I'm going to use the slope-intercept formula to do that. We can do that a little bit later. I just want to get good values out of this first. So maybe when this happens, it prints it out. So I'm going to put this on a new line because I think this is really slowing it down. Just this by itself, it takes a lot of clock cycles to do something. So I should see this climb up much faster now. So let's try that and see. Okay, yeah, look at that. You see how much faster that is? It's because of this was taking up so many clock cycles. And that's one of the things that I talk about a lot in programming, in microcontroller programming. If you're working on a critical system, then you need to really dig deep and find out where those clock cycles are being used and use them effectively. And also a state machine is the best way to do it because you can set priority to various features of your program. All right, so let's go ahead and try this and see what happens. Actually, I kind of want to slow it down now, don't I? Let me go 4000 because I'm not going to be able to see any change. See the actual value. No. Let me go back to 40,000, which we had before. Okay, so the 4096 is the 2000 G mark, and the 0 would be negative 2000 G. Yeah, the OLED write string. And Gorst, thank you for coming in. How are you doing? Which takes a lot of time. Do you have I2C set to 1? No, I have it set to 1 megahertz actually. It's in fast mode. All right, so let's go ahead and play. So this should slow it down quite a bit because I changed it to 40,000. Okay, that's good. I think I may want to change it to even. Well, let's see what happens when I hit it. All right, so we got the hammer all set up. Let's try it. Oh wait, you need to see something, don't you? That's still going to be too slow, or too fast to see. No, we're not going to be able to see anything. Man, we're going to have to put another 0 in here or what? We got it going at 48 megahertz. That's why it's going so fast. Yes, it is fast, but it's working. We've got stuff on the screen. All right, so let's see if we can get something really high here. No. Am I even getting the right one? 2052. Oh my God, I just took a piece out. Almost hit my arm. I need to get a wider or a larger area here. 43. I can't really see it. It's not fast enough. Wait, hold on a second. Am I doing this right? No, yeah, I'm doing it right. Yeah, I wanted to keep the highest value. All right, it's reflashing. No, it's going to take too long. Yeah, let me change it back. That's too many zeros. Let's go with 900,000. We can also show the count. No, I don't want to show the count. That would be stupid. Yeah, no, that's probably good. 2050. Did we see something larger there? Yes, there is coming from the sensor because 0G is at the half point between the 0 and 3.3 volts, the reference voltage, which is around 2000. So just like you saw the raw value before, I can change this to the raw value. This is just a raw value from the actual sensor. And I know it works because we were doing this in the STM studio before and we saw spikes when it's hitting. Remember, this is a 2000 G accelerometer. This is a very, very high G. This is like sensors that are using car crashes and things like that. I could continually hit it, but it's going to take a hard hit. I'm going to change this down to, oops, a smaller number here. Well, no, it doesn't matter. It doesn't matter. This is only when it changes. So if I bring this stuff back out, you'll see change. Well, we're trying to get the shock. Rubber is just going to, I think a piece of rubber is going to dampen it where you won't see anything at all. So you can see it's hovering around 2000. That's the midpoint. That would be 0 Gs. And it would, with a 2000 G accelerometer, that's pretty much 0. I mean, if it wouldn't even show 1G because of the change is 1G is an entire, there's like 3 Gs in one, or 4 Gs in a single, no, it's because it's plus and minus. So from 2000 to 4000, that's about that's about 2000, that's around 2000. So it's about 1G per increment of decimal. So this is the raw number. This is the raw value. If I had nothing in this tie strip for 15, you'd see the number 0 there. So it's definitely getting a value. And I still, like I said before, I know there's value there because I can. We looked at it on the STM Studio, so there were spikes there. So I'm going to continue. I'm going to keep going on. I'm going to keep seeing if I can get a good. Maybe I change the material because maybe there's still too much dampening in this piece of material here. Maybe if I use metal, or I use 2 hammers together. Yeah, let me try hitting another piece of metal. I'm going to try using the hammer. This hammer right here has a 400G accelerometer on it that I was testing, and I have another video out there that shows you how this works. It was showing the SPI communication, and that wasn't done too long ago. It's maybe a couple months ago. So if I hit these 2 together, there should be at least a ringing. Oh, I want to change it to the max and change this. Go back. Disconnect the sensor power. You don't believe me, do you? All right, here we go. Sensor power is gone. Now we have 3696. We have close to 4,000, or well, we have close to 3.3 volts here. I can't print all 3 axes because only 2 of them will work, but I will do that. We should go back to the 2000s here in a second. Yeah. Let's do, I'm gonna make it so this, let's create a new variable. Print it is equal to 0. All right, so print it. I'm gonna put print it should equal to 1. I wish there were bools in C. If I put a capacitor on here, I'm going to have to hook up my my oscilloscope and see the condition of that line to see what happens. The ADC X max is supposed to maintain the maximum value, so that essentially is doing that. I think that's what you're saying. Unless I'm wrong, let me know if you can elaborate on that. Hey Peter, how's it going? Thank you for coming in. Hi, I think C added the bool type as _bool. Oh, that'll be interesting to know. They couldn't just call it bool because legacy code might be using it already. Let me see if that actually works. Hey, check that out. And is it still 0, 1? Let's try it. Should be the same, right? And I wouldn't even have to do this. I could just say if print it, right? I'll keep it at 1 for now. Oh, equals equals. Okay, so let's try this and see if we get any errors. No errors. Amazing. No errors. Still seems to work. Although it's maintaining 2001. Let's see if something happens if I hit these 2 together. Nothing. Oh, it's working. It's working. You see that? It's going into the negative value. Oh, I didn't print out the other ones, did I? I printed it on the same line. So I'm gonna have to line. Set line will equal, in this case it'll be 4, and in this case it'll be 5, the next one. Programming is fun. Yeah, why did I do this whole thing, right? Okay, so set line. Let me initialize it first. I'll make it 4 first. Did I set line? How's it going? Oh, CNC, how's it going, man? Thank you for coming in. Oh, oh yeah, I could probably do that too, couldn't I? Bob gave me another sprintf. Let me try this first and see if this works. Because it's going to be doing it at a different time too. So you may not always get the same, you may not always have an X value. So yeah, and it could take longer, couldn't it? If I did both at the same time. This would save half of the clock cycles if I do it this way, I think. All right, let's try it. I should just get another piece of metal instead of using this. You're always welcome, CNC, of course. And everybody, if anybody wants to see some cool stuff on his channel, he's getting into CNC himself and showing the process and all kinds of other things related to CNC. All right, so let me run it. I haven't run it yet. Shout out to CNC. And if anybody else has a shout out for anything else, Go ahead, I don't mind. All right, so now we should have two lines. All right. Oh, we saw some stuff happen, so that's good. But we don't have two lines, so what's going on here? Oh, that's Z. That's Z. I'm on the wrong one. Come on, guys, you're supposed to help me out. You know what? Maybe I was looking at the Y. The Y-axis is maybe the one that I should have been looking at. I'll put them on their own lines, just so it's a little bit easier to read. Okay, so the X and the Y, the ones that I'm actually reading, let's do it again. Oh, gosh. Hold on. All right. Yeah, that's why you're not helping me out. So I had this right here, I had that over here, and I had this over here. So I was reading the wrong values. So now we should get two lines. Yes, nice. All right, let's try it out and see what happens. Okay, I'm thinking that the Y-axis is in this direction, and we were not reading the correct axis. That sounds right to me. I'm going to try the wood again. All right, so it should be the bottom number. That's 1997. Nothing. Still didn't get anything. 1948. That was a good number, I think. Nope. All right, we got something in the 1800s. So it's working. But metal on metal seems to be a lot better, a lot more reliable of a number. Yeah, I think it's more about ringing too. All right, hammer on hammer action. Yep. Let's see, you don't need to see it, you just need to feel it. That's right, use the force. That's why I suggested printing all three axes. Yeah, I just have a feeling that the more I print at once, the more clock cycles it's going to take. So just printing what it needs to print, I think is probably the best way to do it. But I don't, I could be wrong, completely wrong. All right, so, oh, you saw there's no way you saw 7,000. If you saw 7,000, then that is an anomaly. All right, let's try it again. Let's see if we can see any odd numbers. In fact, yeah, let's do that. 1,100. Oh, wait, we got 100. We got one with 100. I'm not even looking. Okay, so that was in the negative. 3,000 was in the other direction. So there is ringing going on. So hitting metal on metal isn't the best thing to do. Turn the hammer over. Yeah, let's do the side view. So like this. So we should get something on the first line. I don't want to hit like something crucial here. We're not getting anything. This must be the Z. No, the Z is this way. Is like this way. And I don't want to hit that. We're still getting numbers on the Y. We got 1,300. All right, so I guess we could do a conversion to actual G-force. If you want to see that. So we can use the slope-intercept formula for that. All right, so let's slope-intercept formula. We have the slope. Okay, so it's, what is it? Y is equal to mx plus b, right? So we have the slope and we have the offset. The offset is probably going to be 2,000. So the mx is going to be, this is the slope, and the x, let's see, what would that be? We could do well, we can always ask ChatGPT. Let's cheat. Let's cheat a little bit. So what I was doing, you didn't see the code. So the slope-intercept formula is y equals mx plus b. And I'm thinking b is going to be the 2,000 because that would be 0. That would shift it, offset it to the 0 mark. Let's use the AI revolution the way we should, right? Let's see what it says. Okay, so that's the ADC plus b. I see, what would plus c? Okay, so all right, minus 1.908. Okay, so from 2 to 0G is 49.6 minus, okay, that makes sense. So this would be the slope. I thought the b would be 2,000, but I was wrong. Okay. And then the b is equal to 0 minus 1. Okay, so because of it's already being converted, I guess. Yeah. Well, let's try it. So let's take this coefficient and then multiply this by the ADC. And then this is going to have to be a float. So we're going to have to convert the ADC value to a float as well. Let's make it the max value. So 1.908. So this needs to be converted to a float. So how do I do that? I can't remember. Peter, is the floating point of the CPU enabled by default? Well, I don't know what that means, but I can definitely use a float in this controller for sure, because I've done it many times. So I just create the float value. Okay, so float. All right, let's do that. I was remembering it was just the F, but I think that's just from a number. So maybe I have to put F here and F here. I think this is what I remembered doing before. So I'm casting it here. Right, it doesn't have an FPU, but it can still calculate floats. So it doesn't have a floating point unit, essentially. No, it's not that advanced. Okay, so this should work, right? So I should, let me, yeah, I already got GeForce there. And I can do this as well. And then I need to print, this will become the buffer. Let's see, hold on a second. Where am I doing that? Oh wait, look at this. I wasn't doing this right at all, was I? Alrighty. All right, let's hold off on this for a moment. Let me get this other stuff right first. Why didn't anybody see this? Thank you, CNC. I appreciate the $2. Man, that's so generous of you. You need to stop giving me super chats, seriously. You give me a super chat almost in every one of these, and I really do appreciate it. But I'm very grateful. So thank you so much. Yeah. Let's see. You will need to change your sprintf for floating point. Okay. Yeah, I will definitely do that. So what is this value going to be? It does software floating point. Yeah, on some STM32s you have. What the hell? All right. Thank you, CNC. I really do appreciate it. The $2 is going to go in to a very, it's very needy place. So thank you so much. I really appreciate it. Okay. Yeah, it's an integer, but I'm casting it as a float here. But before I do that, I've been printing out the X value the whole time, not the Y. So I need to make, because I want to be printing out the Y value on the second line, right? Not the X value all the time. So maybe I should just pass in, maybe I should make this its own function. By the way, it's 3 o'clock, but I'm going to go over because with the fiasco on the beginning of this this live stream, I'll go over around 40 minutes. So at 3:40 I'll stop this this live stream. So I'm thinking we should put this in its own function. Okay, %f. I'll change that first. And thank you, Anant. Welcome, Anant. Hello. I don't think I've seen you here before, so I really appreciate it. You coming in. So welcome. All right, so let's see. Okay, so I'm gonna go ahead and, so x equals, and I think you were saying this before. Let's go ahead and do that. Let's go ahead and do what you were saying before. Even though it's gonna use more clock cycles, I'm gonna go ahead and do what you were saying before. So I like that. I'm gonna increase also the buffer. I'm gonna go to 20, so I can put more stuff here. So percent 04.2. I have no idea what that is. 04.2. So I'm thinking it's 4 digits for this side of the decimal place and 2 precision. This is what I'm assuming, right? Yeah, okay, good. Yeah, I like that, I like that. Oh my God, you need to go to sleep, CNC. Maybe that's why you continually give me money, because you're delirious. Okay, yeah, cool. Nice. All right, so I'm gonna do 2 of these. But first I'm going to set the line. Wait, no, yeah. Wait, hold on. I need to do, should I do 2 of these like this, but have the buffer be like a different buffer? Or is there a way I can put both of them on the same line? I think you said that earlier. Let's try that. Yeah, I'm going to do this one right here. You mentioned this before, so I'm going to go ahead and do this. Thank you, Bob, by the way. That was Bob's. So I'm going to go ahead and get rid of this one. So this should work, right? But I don't know if it's all going to fit in one line. Oh yeah, it should. So let's do that. And let's put the 0.2 and then F. 0.2 and F. And it shouldn't be the ADC value, it should be the G4. Oh no, I'm going to do this first. D. Wait, what would you have before? Wrong. Yeah, let's do this first. Four digits. Peter, let's see if the floats get printed as 0 because the F formatting code isn't included in default. Yeah, let me do this right after. Let's do this right after, by the way, Christensen. Oh yeah, As Langvald Christensen. Oh yeah, I think I said hello to you earlier. And if I didn't say hello. Let's do this first just to see if I get these values both on the same line. and the correct values because I was using only the X. Let me go Y. So I should have Y there. Now let's try this first. Maybe I'll get completely different values than I did before. So X is definitely in the beginning, the first one, and Y is definitely in the next one. Oh, I did it twice. What the hell? Oh, right. I don't need to have that anymore. The print it, or the set line actually. So let's do that again. It's always going to be 4 anyway. Yes, there are a lot of familiar faces here now because of I'm trying to build a community and it's just happening by itself. It's really good. All right, so let's see what happens with the X and Y now. So X is in this direction, I think. Oh wait, you're not seeing what I'm seeing. Hold on a second. Let's go back to this one. Okay, so now you can see the hammers. All right. Oh wait, you can't see the, here we go. All right. Okay, so let's see if we see values happen. Yep, 1875, 1970. It's weird it's happening on both. I think X, this is definitely X in this direction. 1620, 1839, that one didn't work at all. So I think I'm not getting all the values. I saw 15. Now I'm going to do it in this direction. Although I'm going to be hitting the wires. I don't know if I should do that. Still showing the X mostly. 1500, so this is definitely X. Yeah, 1400. This is definitely the X value. All right, let's go back to looking at the G-force calculation. Time travel hammers. Peter says these look like time. Yeah, totally. Yeah, the shock is creating a rift in time. Okay, so Gorazd, yes, but you print out the current value. You would see better if you print out the max values. Oh, that's right. Oh my God, I'm not doing this right. Thank you very much. It's pretty cool that I'm getting the max though. I mean the current values. That was interesting. All right, so let's do it now. ADC X max, ADC Y max. Thank you for pointing that out. Let's go ahead and run it. All right, let's try it again. That's weird. There's something wrong in the code, I think. Something definitely is wrong in the code. It is very useful. The pulse is very short. Yeah, no, the pulse is probably shorter than, or very, very close to the clock cycle. What we saw in the ADC or the STM Studio, it was pretty short, and we weren't getting the spike at all at some instances. So this is definitely going to be the best way to do it, but not the best, but an effective way to do it. But that's weird. I'm not getting the same values. Let me shorten this a little bit. Let me go to 9,000. But it should be getting a. Oh wait. That's why greater than. Yeah, Gorazd, you said. Yeah, I went to 2200, but that was in the wrong direction. So it should be I should be changing this to a less than. So maybe what I do is I have to have 2 maxes, like one that goes under 2000 and one that goes over 2000. Why does it do that? Right? Does that make more sense? Absolute value. Oh, what I could do, no, I don't want to do that. Because it's always going to swing either lower than 2000 or above 2000 because it's plus or minus 2000 G. No, I'm not using the absolute value. But if the ADC value is less than Y max, which is going to be 2000, I think this will work. Let's try it. I like to see if things work. Oh wait, you can't see the. All right, what I did was I just switched over the greater than to less than. So now it will show you max values that are lower than the 2000 rather than above 2000, because we saw the values going smaller, not bigger. So let's try that. Now there we go. Well, I think I also sped it up, so we may have to slow it down again. Let me change it back here. This is not working. Somebody tell me what's wrong. If the X value is less than ADC max, okay, so the ADC, it will go smaller. That should be right. Let me increase this so we actually see something and doesn't just disappear on us. We'll go the way we had it before. We'll do 100,000. Let's see if that works. Is that still too fast? What am I doing wrong? So if the X value, the raw value, is less than the ADC max, then ADC max is going to equal the X value, because that's going to get lower. There you go. How's that? This should work, because we could see the values with the value, and I could call it min, but I mean that's just nomenclature at that point. Just so it sets it up in our minds that it's the minimum. Well, it's being reset here every 100,000 I could increase that, but it's outside the loop. The buffer is this is being reinitialized every time it counts up to, but the initial initialization is up here, way outside. It's a global variable. Let me just increase this, go back to 900,000. Let's try it and see. I'm going to keep this, I'll change it so you can see me hammering as well. Huh, okay. It's weird that it's moving so fast. Yeah, I see it. I'm trying really hard to hit it, really hard, and look at the screen at the same time. So I may not actually hit it. Okay, it's working. But still, this may be too fast. If I put another 0 in it, no, that doesn't make any sense though. Oh, where's the count? The count is up here. Okay, so that's fine. You're not seeing what I'm seeing. If count is greater than 0, the type of count is int, so it has a long way to go. Although, no, you're right. What is the maximum value of an integer? It's got to be more than this. What is the max value of an int in C? It's a 32-bit. Well, if I use the 32-bit, I guess. I could use the unsigned integer of 32-bit. A long, I could use long. Yeah, let's use long instead. But this is probably the, let's use long. Does long exist in the C types? I don't think I've ever used long. I could do that too, uint 32_t. Let's do that. Yeah, let's do this instead. That way I know I'm using a 32-bit integer. And I can also, well, let's just see what kind of timing we get anyway. Because the standard int should be a lot larger than that. Let's see what happens when I just go ahead and play it and see how this changes. All right, we don't see anything there yet. But now we start seeing it change a lot, relatively fast. I think we need to print something out here. I'm going to print out, not count, but I'm going to do another count inside of this. Okay, Skeptic is saying if absolute value of the ADC value minus 2000 is greater than absolute max equals ADC value minus 2000, you'll have both directions. Okay, cool. Yeah, that's good. I'll do that next time. I'll do that on Wednesday. But right now, I just want to see if I can get a count, just real quick. But then I'm going to need to do this again. I'll use the same buffer. I'll just do %d, just as to bring this home. Oh, Control Z. No, count inside count. Is that the right way I put it in? There we go. I don't know why I had an equals there. All right, so now I need to ++. Okay, so at least I'll see a count of how many times it's counting up through this process. Yeah, I'll do that. I'll use the unsigned integer 32-bit. What is that pause in the beginning? Okay. Isn't it weird that it's changing constantly? Oh wait, I know why. Because that's only when it has to reset back to 2000. So it's always counting. Yeah. No, that makes sense. It makes sense. So this should be much shorter. So what is 90,000? Yeah, this is better. I like this better. Okay. All right. And I'm going to change all of the ints to uint 32s because Bob told me to. And I'm going to, what is this? We got this error again. Oh, well, it doesn't matter. Oh, wait. I don't want that. Yeah, that makes sense. All right. So I'm going to stop there. I'm going to run this again. And next time we'll do the absolute value and get both sides and use Skeptic's idea. I'm going to change this, let's see, properties. I'm going to put this as a reminder on the top right corner of the screen so I know what to do next time. Both sides of 2000. Yes, and the max value should be a signed integer. Yes, so I'm going to, Skeptic says that, and we'll do that also next time. So I'm going to put a quick note in here. No, I'm going to put it inside of the while loop because I'm going to forget to go up there. I can't miss that, right? I'm sure one of you will remind me as well. Yes, the plus VE and the minus VE for sure. Yeah, I could do that too. Lars Christensen is stating that if it is a 12-bit converter and 0 is in the middle, you just need to XOR the most significant bit to get signed. Okay, yeah, we can do that. We can explore that the next time, but we can see that it's incrementing at a pretty good rate. So this could be a good way to get values in a time we can still see them. So I think we've made progress today, and thank you everyone for coming in the beginning and dealing with the failure of my my keyboard. And also I am going to be coming back online live streaming tomorrow at 1 o'clock, and we will look into CNC stuff, and I'll probably also I'm going to be enclosing my 3D printer stuff, so I want to explore that as well. So I'll be taking questions, doing that stuff. I also need to lathe my what is it? The machine that cures my resin prints, and I'm going to make that thing open up in the front as well. So I'll probably be using the laser tomorrow as well. I want to get that stuff done. I need to get that stuff done so I don't inhale anymore, and I try to extend my life. So until then, see everyone later. Thank you everyone for coming in. I'm very very happy, and I have a lot of gratitude for everybody that comes in and watches these live streams. So thank you so much.